Hi, okay, this is part 2 of lesson 7, and we continue where we left off with part 1, and we'll continue to talk about variables. And you'll see later on why variables are very important in computer programming. Okay, so here I wrote some sort of a program. It's not really it could be a program, but I'm not specifying any computer programming language or anything else, and the syntax is not specific to any language. I just want to show you this for the purpose of seeing what's going on with the variables. And in this silly program, and you'll see why it's silly, there are two variables. One of them is called A and the other one is called B. The reason it's silly is because I'm setting it to different value for no reason. For example, I say A equals to 7, that means put 7 in the variable A, and then I say A equals to A minus 3 without any apparent reason, without an if question, without any logic, and then I set the value of B to 10, and I say B equals 2 times B, so it has no real meaning. The only reason for this program is to show you the values that A and B are receiving at every different command that's here in the program. We have 1, 2, 3, 4, 5, 6, 7 commands. And the program is executed normally from top to bottom, and we read it from left to right like we read English. So here I have another thing, and this is another term that you have to learn. It's called dry run. Dry run meaning you go through the program and you try to simulate what the computer will do. But you're not a computer, you're a human being, so that's why it's called a dry run. So let's dry run this program and see what the values are that A and B are getting at every command. So when we execute command number 1, A gets the value of 7. So we'll write under A, we'll write 7. And then the next command is A equals A minus 3. So we have to deduct 3 from A, and that makes 7 minus 3 is going to be equal to 4, right? Because our last A was 4 or 7. So A minus 3 is 7 minus 3 and is equal 4. So now the new A in this command, we executed this, now we execute this. After the second command, A will have the value 4. Agree? B doesn't have a value yet because we didn't encounter B. In the third command, we'll see B equals to 10. So we assign the value 10 to the variable B, and now we can already write here that B is equal to 10, and we proceed to command number 4. Command number 4 says B equals 2 times B, and times is signified as a star or asterisk in computer science. Usually star means times, and that's above the digit 8. So shift 8 will give us the asterisk. B equals 2 times B. The last B was 10, and 2 times 10 is 20. That's simple enough. So now B will have the value of 20. Because we took the last value, which was 10, multiplied it by 2, and the result went back into B. So B is 20. Next command says B equals B minus 12. So now we take the last B here, which is 20, we deduct 12 from it, and we'll have, and then the result will go back into B. So this will be 8, as you guessed, because 20 minus 12 is 8. Next command, A equals 3 times A plus 4 times B. So we take the last values of A and B. A was 4, we multiply it by 3, so we get 12. b was 8, we multiplied by 4, we get 32. So 12 plus 32 is going to be 44, I think. And then we enter it back into A. So A will have the value now of 44. Again, just to repeat that quickly, since A was 4, 3 times A is 12, and B was 8, 4 times 8 is 32, 12 plus 32 is 44. So A is now 44 because this whole thing goes back into A. And now the last command tells us print A, comma B. So the last value of A is 44. So the program will print 44. And the last value of B is 8. So the program will print, instead of B, 8. So this is the end result of the program. It will print two numbers, whatever is in the variable A, which was last 44, and whatever was last in the variable B, which is 8. It will not print 4, it will not print 7, it will not print 20, and it will not print 10, although all those values at some point in time were inside the variables A and B. But since we executed the program from top to bottom, we went all the way through here, and the commands just overrode the values one after the other of A and B, and the final result was A equals 44 and B equals 8. So this is how the variable thing works. Whatever is entered into the variable last is the value that's in the variable. Now, to go back to something that I mentioned before, we talked about a compiler. A compiler is simply a program that takes high-level language and turns it into machine language. So we'll write here H for high level, and we'll write here for machine, and this here will be a compiler, which is a new word for you, but it's a word that's very popular in computer science. So sooner or later you'll see this word in many places. So a compiler is something that interprets a program that we write in high level into a machine language that the computer can understand. So we always need a compiler in order for the computer to understand our language, because we write in high language, and as I said, the computer can understand machine language. So I'll give you a small exercise to think about, and maybe write a flow chart. And the exercise is such that think about a program that does this. It reads a number from input, and it doesn't matter right now what the input is. We'll talk about input later. It reads a number into a variable. Then 2, it checks if the number is odd or even. And 3, if the number is odd, it prints odd. If the number is even, it prints even. So think about this program and try to draw maybe a flow chart that will execute the commands that we have here. And think about how to tell if a number is odd and even, and we will deploy that methodology in our program. But first, try to come up with a flow chart, and I'll talk more about it in the part 3 of lesson 7. So for the time being, just think about what to do here, and if you figure out the flow chart, put it down on paper. So this is it for right now, and we'll proceed later with part 3 of lesson 7.